All right, geometry. So now we're looking at section 6.3, proving that a quadrilateral is a parallelogram. So you're going to see a couple different theorems in this section, and you're going to think they look very familiar. And I hope this word converse pops in your head. Very similar to our parallel lines discussion, right? We started with if you're given parallel lines, then you have congruent angles, supplementary angles. Well, now, same thing here. We're going to go backwards from that. So just like in sections 3.2 and 3.3, we said, okay, well, now we have these angle pair relationships. Now the lines are parallel. Same thing here. You're going to see that one of those 5 properties from section 6.2 are true. So now you can tell me that the quadrilateral is a parallelogram. So we're arriving at the fact that it is a parallelogram. We don't know it's a parallelogram. All right, so again, think of the wording, right? If both pairs of opposite sides of a quadrilateral is congruent, then the quadrilateral is a parallelogram. Both pairs opposite sides congruent, then the quadrilateral is a parallelogram. Then ABCD is a parallelogram. Again, converse. This is the converse from section 6.2. Okay, same thing here and here. I'm not going to do a lot of drawing. So again, if you have an angle, so this is a little bit different. If you have an angle, one angle, supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So again, in this case, you have A, right here, A, supplementary to B, and supplementary to D. That's enough to say that it's a parallelogram. Okay? So be aware of that. And again, it's this idea of, this would be able to show that, if A and B are supplementary, then that means that these two lines are parallel. If A and D are supplementary, then that's enough to show that these two lines are parallel. And now you have both pairs of opposite sides parallel. It is a parallelogram. Here we go. Opposite angles. So now if your opposite angles are congruent, then you know your quadrilateral is a parallelogram. So again, both pairs of opposite angles, then you have a parallelogram. Your diagonals, again, if your diagonals bisect each other, then your quadrilateral is a parallelogram. So again, both diagonals have to bisect each other. Great. And then this was a little bit special. This is the only one that's not a converse. Not a converse. So I always like to, in math, you should always point out the weird things, the things that don't follow a pattern. So it says if one pair of opposite sides is both congruent and parallel. So one pair of opposite sides both congruent and parallel, then it's also a parallelogram. And again, you can see this picture here. Typically, it's both pairs of opposite sides being congruent or both pairs of opposite sides being parallel. Now you have one pair being congruent and parallel. Okay. And then last but not least, kind of a summary slide. So here we go. This is all the different ways that you can prove a quadrilateral is a parallelogram. Prove that both pairs of opposite sides are parallel. That's the one that I like to do the most. And if we do some proofs, which I think we will, I will do it that way. But you can prove both pairs of opposite sides congruent. Prove that an angle is supplementary to both of its consecutive angles. Prove that both pairs of opposite angles are congruent. Prove that the diagonals bisect each other. And again, this is the different one, prove that one pair of opposite sides is congruent and parallel. Okay, so I'm going to go ahead and make a separate video for a proof on proving that a quadrilateral is a parallelogram.